Imagine stepping into a room and sunlight is just flooding every corner.
Yeah.
Bright, expansive, almost wrapping you up.
Yeah, that feeling of openness.
Or maybe you're outside gazing up at a massive skyscraper, its surface shimmering, reflecting the whole city back at you.
Mm-hmm.
That barrier, that seemingly invisible separation between you and the world outside, yet it connects you, right?
That's glass.
It's everywhere now. So common.
Exactly. So common we barely notice it sometimes. Like, it's always been this way. But in architecture, wow, it's been nothing short of a revolution.
A huge shift.
It quite literally helped, as the saying goes, dematerialize the solid wall. And it completely reshaped our relationship with buildings, with light, with the environment around us.
Absolutely fundamental changes.
So today we're going on a deep dive into the journey of glass in architecture. It's fascinating and honestly, sometimes a bit contradictory.
It has its paradoxes for sure.
Our mission really is to trace its story, from being this super rare, precious luxury item, maybe used for tiny little things.
Jewels, small panes. Right. To becoming the actual skin of our tallest buildings. And now it's evolved into this high-performance, critical piece of modern building science.
It's a really complex component.
We want to uncover those incredible tech leaps that made it all possible. Look at iconic structures, the Crystal Palace, obviously.
Yeah, can't talk glass without the Crystal Palace.
And really get into the whole aesthetic side, the philosophy of transparency. What does it mean to see through walls?
And the flip side, too.
Oh, definitely. We have to confront the big challenges glass buildings throw at us, especially energy and, the environmental impact.
Huge considerations today.
It's a story packed with ambition, amazing innovation, but also some really surprising, maybe even paradoxical consequences that are still shaping our skylines right now. Okay, so let's start by winding things way, way back. Before glass was just everywhere. Think about antiquity. Glass wasn't this everyday thing at all.
Not even close. It was rare.
Precious.
Almost mystical, right? Imagine a time it was so valuable it was only used for tiny, exquisite things. Decorations, maybe jewelry, or maybe the most exclusive tiny window panes. Almost like gems set into a wall.
Totally. An unbelievable luxury. It certainly didn't define the building itself.
Yeah, buildings were solid, substantial, for millennia.
That's the key difference, isn't it? For thousands of years, building meant heavy, opaque materials. Massive stones, thick wood timbers, dense masonry.
Materials that did double-duty structure and enclosure.
Right. They held the building up and they kept the weather out. It created a very different kind of internal space than we're used to.
Much heavier, darker, often.
And our sources give us a great picture of this. Even as late as the 12th century, finding big trees for construction was tough.
Forests had been heavily used, depleted in many areas.
Which really limited your options for timber framing. So builders often defaulted to what was nearby. Stone from local quarries became the standard.
Not always by choice, but because moving heavy stuff long distances was incredibly hard. Logistics dictated design in a way.
It literally shaped the form, the scale, the look of buildings, what you could get your hands on nearby.
And think about the comfort inside those buildings. Light, warmth, totally different story.
Oh, absolutely. Imagine the cold, the drafts, before we had decent windows. Louis Sullivan, the pioneering American architect.
Famous for his skyscrapers later on.
In his autobiography, he paints this incredibly vivid picture. He talks about being woken up by the rattling sash of the window.
You can just hear it.
And the sharp wind moaning through the cracks. Waking up so cold he'd have to break the skin of ice at the picture's top just to wash his face.
Wow. That really brings it home.
It does. Those small, precious glass panes, they offered almost no real protection.
Yeah.
It was a world of heavy, enclosed, often drafty spaces. The outside stayed very much outside.
And that whole context, what materials were available, how hard they were to work with, how they actually performed, that's so critical when we think about traditional architectural ideas. Well, early theorists, the big names like Vitruvius back in Roman times, they based everything on the inherent qualities of the materials themselves.
The material wanted to do, sort of.
Exactly, how it behaved. Vitruvius would specify, stone or marble for architraves because of their strength in spanning and opening. Or columns had to have very specific proportions, and those proportions were directly tied to the material they were made of.
So the design grew out of the material.
Precisely. The weight of materials, their substance, their strengths, their limitations, that was absolutely central to how buildings were designed and built. It was an architecture deeply rooted in the physical stuff it was made from.
Okay, that makes sense. It's very practical, grounded.
And this understanding leads right into a really fundamental idea, especially later on: truth to materials.
I've heard that phrase.
It really highlights just how radical the shift to glass eventually was. Someone like Viollet-le-Duc, a huge figure in 19th century architecture and theory.
French architect, right.
Big
restorer of cathedral.
That's him. He was passionate about this. He argued, look, if your local quarry gives you these fantastic, massive stone blocks, use them as massive blocks.
Don't chop them up.
Right. Don't cut them into tiny pieces just to mimic, say, a Roman wall made of small marble slabs. That, he said, would be a lion's stone. It wouldn't have style because it wasn't true to the material's nature or the honest way of using it.
So authenticity was key.
Absolutely. His core principle was clear and incredibly influential. When you change the material or the manner of employing it, you should change the form.
Okay, I see where you're going. That idea directly challenges those old, solid, load-bearing walls.
It does. And maybe without even realizing it fully at the time, it lays the philosophical groundwork for how a transparent, non-load-bearing material like glass wouldn't just allow new forms, it would practically demand them.
Because you're changing the materials, you have to change the form.
Exactly. And what's also interesting is how even the idea of ornament, decoration, has shifted over time.
We tend to think of older buildings as being heavily ornamented. Carvings, moldings.
And often they were. Vitruvius, back again, he devoted a whole chapter 6, just to the ornaments of the orders. For him, these weren't just stuck on, they were integral part of the system, conveying meaning.
Like the scrolls on an Ionic column capital.
Precisely. But fast forward centuries and you get the stirrings of modernism. Figures like Adolf Loos, the Austrian architect, famously declaring in 1908, "Ornament is crime."
Wow, that's blunt.
It was. He pushed for a stark, functional look, arguing ornament was wasteful, even morally suspect.
So a complete rejection.
Pretty much. And this whole journey from ornament being essential to it being rejected kind of sets the stage perfectly for a time when transparency itself, the lack of applied decoration, the pure form could become its own powerful aesthetic statement.
Like the glass itself is the statement.
Exactly. The smoothness, the light, the reflection that becomes the beauty, it aligns perfectly with that emerging minimalist feeling. So the material and the philosophy start to meet.
That's fascinating. Transparency as its own kind of non-ornament ornament.
Yeah.
Okay, so if glass was rare for ages and traditional building was all about solid, maybe ornamented walls, what actually happened to unlock glass? What allowed it to become this transformative force?
The 19th century. That was the crucible. A huge technological leap forward where glass really met iron and boom, architectural revolution.
What changed in glassmaking?
Massive advancements. We moved way beyond those small, expensive, often bubbly or wavy panes. Industrial processes came online, especially things like the plate glass process.
Plate glass, what's that?
Basically, a method to produce much larger, much clearer and flatter, more uniform sheets of glass than ever before. Suddenly, glass wasn't just a tiny jewel, it could be a proper building component, a big one.
Ah, okay. Scale and clarity, that's key.
And this wasn't happening in isolation. It wasn't just glass getting industrialized.
Other materials too.
Yeah, it was a broader trend across building materials, driven by the Industrial Revolution. Think about bricks, for example. Around 1830, in East Anglia, England, white brick manufacturing really took off.
Like specific types.
Yeah, these distinctive causey whites or wool pit bricks. And the amazing thing is they could transport these bricks as far afield as Washington, D.C. for use in huge projects like the Capitol building.
Wow, from England to Washington. That's incredible logistics for the 1830s.
It really shows this trend. Mass production, wider distribution. Architects suddenly had this whole new palette of materials industrially produced, consistent, available in quantity with new properties. It just invited them to think differently, to experiment.
And the ultimate symbol of this new age, the poster child for glass and iron, has to be the Crystal Palace, right? 1851.
Absolutely, the turning point. That huge exhibition hall for the Great Exhibition in London. It wasn't just a building. It was this dazzling, almost unbelievable statement.
Built mainly of glass and cast iron.
Oh, tons of it. An unprecedented amount. It really felt like a people's palace, this grand, light-filled, accessible public space, totally different from anything most people had ever experienced.
A symbol of modernity, progress.
And a bold declaration of what these new technologies could do when you pushed them.
But building something that massive, that new, it must have been a huge engineering challenge. Were there risks?
Oh, definitely. And they knew it. Even then, our sources from the time point out that Cast iron columns will generally fail in fire and water sooner than wooden columns.
So iron wasn't necessarily stronger in all situations.
Not inherently fire-resistant, no.
Yeah.
Especially cast iron, which can be brittle. And they also understood that fireproofing steel beams and girders is necessary to make them as fire-resistant as the floors they support.
So even as they were building these amazing new things, they were also figuring out the new problems they created.
Exactly. New materials, new capabilities, but also new vulnerabilities, new design challenges to solve. And interestingly, there was also a subtle shift happening with the look of iron itself around then.
How so?
Well, earlier Regency ironwork, railings, balconies, it's often described as lighter and more mechanical yet nearly always graceful, often quite decorative.
Yeah, you see intricate patterns.
But after about 1830, sources note a rapid deterioration in the artistic quality of decorative architectural ironwork.
It got less fancy.
Kind of. It suggests a move towards more functional, maybe less ornamented uses of iron. And maybe, just maybe, that aesthetic shift towards plainer forms helped pave the way for the really clean lines of the all-glass architecture that was coming next, where the material itself, not the added decoration, was the star. So that whole journey, glass becoming industrialized, teaming up with iron and things like the Crystal Palace, that really set the stage for maybe the biggest leap in modern architecture. The curtain wall.
The curtain wall. Okay, what exactly is that?
It's a complete break from thousands of years of tradition. It's what allows for that idea of dematerializing the solid wall.
How does it work?
Okay, think about traditional walls. For almost all of history, the wall held the building up, right? It carried the weight of the floors, the roof. It was load-bearing.
Got it. Structural.
The curtain wall is not that at all. It's non-structural. It's essentially an outer covering, a skin whose main job is just to keep the weather out.
So it just hangs there.
Like a curtain.
Exactly. That's where the name comes from. It's hung or attached to the building's main structural frame, which is usually set back from the edge. The frame does the load-bearing work. The curtain wall is just the envelope.
Wow. Okay, that is a radical shift. The wall stops being the structure.
Totally radical. Rainer Banham had this great phrase, a clip-on architecture.
Yeah.
It really captures that modular, lightweight, non-load-bearing idea. Elements are attached, clipped onto the frame.
Which gives you incredible freedom, I guess.
Huge freedom. Suddenly, the exterior skin is liberated from having to hold everything up, and this freedom coincided with, or maybe fueled, this growing desire for openness.
People wanted bigger, more open spaces inside. Architects and clients, yeah. They started wanting vast interiors, easy of access, with no partitions. Think big, open floor plans.
Like a modern office building.
Exactly. Or, even going back further, functions similar to old Roman basilicas' large, covered public spaces. But now, glass was the key. It was the ultimate enabler for this transparent, light-filled vision. Buildings could finally shed those heavy, opaque skins.
Open up, let light pour in, connect inside and outside.
Precisely. And glass just took off. It wasn't just for fancy showcase buildings anymore. It became ubiquitous.
Everywhere.
Pretty much.
Yeah.
Francis Ching's book, Building Construction Illustrated, points this out clearly. Glass becomes key for entire facades, obviously, but also for everyday things. Glass entrance doors, sliding glass doors, storefronts.
So it's filtering down into regular commercial buildings.
Absolutely. It wasn't just skyscrapers. The transparent revolution, kicked off by the curtain wall, really permeated the whole built environment, changing how even ordinary buildings looked and felt.
It's amazing how a material change ripples out like that. It changes not just how we build, but how we feel in and around buildings.
Definitely. The aesthetic side, the philosophical side, it was huge.
Glass became this powerful symbol, didn't it? Modernity, progress.
Light, openness.
Letting all that daylight flood in, offering these expansive views out. It just dissolved that heavy, fortress-like feeling of older buildings.
Connected inside and outside in a totally new way. Fostered a new relationship with the city, the landscape.
You know, it makes me think again of Louis Sullivan, but in a different way. He talked about his deep connection to nature, like his great friend, that big ash tree he'd greet every day. Glass, in a way, allowed architecture to bring that kind of external connection into the building. The changing light, the seasons, the buzz of the street, the view. It made the boundary permeable.
Almost dissolved the boundary sometimes.
Yeah. And this supported entirely new looks in architecture, too. That clean, purified, crisp look became really influential.
Minimalism starts to emerge.
Think of something like the Petit Trianon at Versailles by Henri Jacques Gabriel, Okay, it's not all glass, obviously, way earlier.
Beautiful neoclassical building.
But its aesthetic described as a pristine cube-like mass with sharp, clean edges, smooth surface bands for moldings, no domes, nor pediments for emphasis. That kind of stripped-down purity really paved the way for forms where transparency could just dominate. The glass could be the main event.
The form becomes very simple, letting the materials speak.
And we should remember, architecture doesn't happen in a bubble, right? Ideas travel.
Always. Cultural exchange is key.
Like how Japanese influence showed up in Frank Lloyd Wright's designs. That reflects a bigger dialogue happening. The embrace of glass, too. It had global roots, different expressions in different places.
Absolutely. Think about Nordic countries where maximizing precious daylight is crucial. Huge glass areas make sense there, maybe handled differently than in, say, Southern California, where you're fighting intense sun.
Right. Same material, different climate, different response. And glass also fundamentally shifted what materials mean, didn't it?
How so?
Well, Carlo Ratti talks about how new tech changes symbolism, like how silicon rather than asphalt, digital infrastructure, is changing what cars represent.
Interesting analogy.
Similarly, glass totally changed what a wall could mean. It went from being about strength, enclosure, privacy,
Solidity. Defense, almost.
to being about openness, connection, maybe even a kind of vulnerability. It challenged our basic ideas about space, light, and what a boundary even is.
It really did. But that initial rush, that excitement about transparency and light, it ran headfirst into some very real, very uncomfortable problems.
The practicalities.
Big time. Rayner Banham wasn't kidding when he called those early glass buildings hothouses.
Because they literally got too hot.
Unbearably hot in summer, all that sunlight pouring in, trapped, classic greenhouse effect. And then in winter, freezing cold, all the heat just radiated straight out through the glass.
So beautiful to look at, maybe, but not great to be inside.
Often not. And incredibly inefficient. The dream of light and connection turned into oppressive heat, blinding glare, or shivering cold. A big gap between the architectural vision and how the materials actually performed.
So it highlights that systems thinking idea, right? You change one thing, the wall material, and it affects everything else, like temperature.
Exactly. Donella Meadows talks about that bathtub analogy, inflows, outflows, stock. Buildings are complex systems. Heat comes in from the sun, people, lights. Heat goes out through the envelope.
And if that envelope is mostly glass, especially early glass,
The outflows in winter can be massive, and the inflows from the sun in summer can be overwhelming. If the furnace just can't keep up with the heat drain, or the AC can't handle the solar gain, the room gets pretty uncomfortable, as Meadows puts it.
and uses a ton of energy trying.
A ton of energy. This discomfort, plus the huge energy waste, became a massive driver for innovation. Architects, engineers, manufacturers, they had to get smarter. They needed high-performance glass.
Okay, so what makes glass high performance? What changed?
Several key things. The focus shifted to strategies like, obviously, better glazing, but also increased thermal resistance in both walls and windows, thinking about natural ventilation, using sensors to optimize daylight.
But the glass itself, what are the big advancements?
Two main game changers. First, insulated glazing units, or IGUs.
Double glazing.
Basically, yeah, but more sophisticated. 2 or even 3 panes of glass sealed together with a space in between. That space is crucial. It's filled with air, or better yet, an inert gas like argon or krypton.
Why gas?
It's a much better insulator than just air. It dramatically slows down heat transfer conduction and convection compared to a single pane. You get much better thermal performance.
Okay, so IGUs are step 1. What's step 2?
Low-emissivity coatings, or low-E coatings, these are amazing. They're microscopically thin, virtually invisible metallic layers applied to one or more surfaces inside the IGU.
And what do they do?
They reflect radiant heat, specifically long-wave infrared radiation. That's the heat you feel. So in winter, they reflect your indoor heat back into the room, keeping it warmer. And in summer, they reflect the sun's heat radiation away from the building, keeping it cooler. And the clever part is, they do this without blocking too much visible light.
So you get the insulation and the light. That's clever.
Very clever. It revolutionized window performance. And beyond those, for really high-end applications, you get things like double skin facades.
Double skin, like 2 layers of curtain wall.
Essentially, yes. Ching mentions them. You have an outer glass layer, then an air cavity, sometimes quite wide, maybe ventilated, and then an inner glass layer.
What's the point of the gap?
It acts as a massive buffer zone, improves thermal insulation even more, helps with acoustics, can integrate shading devices within the cavity, and can even be used for natural ventilation strategies. It's a really sophisticated system for environmental control.
A long way from a single pane of glass in the Crystal Palace.
Worlds apart. But even with the best glass, the details matter hugely. Ceiling, air barriers.
The bits around the edges.
Exactly. Joseph the Steiberek, the building science guru, always emphasizes insulating basements for comfort and efficiency. That same thinking applies to the whole envelope, especially where glass meets the structure. You need meticulous sealing.
To stop drafts and leaks.
Air leaks, moisture leaks, they kill performance. So you use things like flexible backer rod foam strips pushed into joints before sealant goes in.
Why the rod?
It controls the depth of the sealant, ensures it forms the right shape to bond properly and stay flexible. And the sealants themselves, the adhesives, they're critical, not just for holding things together or fire separation, but for creating that continuous thermal and air barrier.
Yeah.
Preventing energy loss.
So it's the fancy glass plus all the careful detailing around it that makes a modern glass facade actually work well.
Absolutely. It's a whole system approach. Those unseen details are what make the difference between a beautiful failure and a high-performance success.
So we've seen glass evolve incredibly, from luxury item to high-tech skin. It's transformed architecture, given us light, views, amazing forms.
Undeniable.
But there's a paradox here, isn't there? Especially with these huge all-glass buildings that are so common now.
An energy paradox is a big one.
Exactly. For all its beauty and transparency, glass, even high-performance glass, lets in a lot of solar heat in the summer. Banham's hothouses problem hasn't entirely gone away.
It's physics. Glass transmits solar radiation readily.
And in winter, it loses heat faster than a well-insulated solid wall. So you end up needing massive amounts of energy for air conditioning in summer and heating in winter.
Fighting the natural tendencies of the material, essentially.
Which is why modern glass buildings need incredibly sophisticated HVAC systems, right?
Yeah.
Way beyond just a simple furnace or AC unit.
Oh, absolutely. Kibert's book on sustainable construction lays it out. We're talking high-efficiency HVAC systems, often VAV systems.
VA.
Variable air volume. Instead of just blasting cold or hot air constantly, it adjusts the volume of air sent to different zones based on actual need. Much smarter. Saves energy.
Okay. And what else?
Often combined with things like cooling towers, secondary chilled water pumps, high-efficiency chillers. And crucially, these are often controlled by variable frequency drives, or VFDs.
VFDs, what do they do?
They allow the motors in pumps and fans to ramp up or down their speed based on demand, instead of just being fully on or fully off. Huge energy saver compared to older systems. It's all about fine-tuning the energy use.
So very complex mechanical systems working behind the scenes.
Very complex. And you also see things like energy recovery ventilators or ERVs.
What's their job?
They handle the fresh air coming into the building. Before the stale indoor air is exhausted, the ERV captures heat in winter or coolness in summer from that outgoing air and transfers it to the incoming fresh air.
So you're preheating or pre-cooling the fresh air using energy you'd otherwise just throw away.
Exactly. Reduces the load on the main heating and cooling systems. Another efficiency gain.
But how do you make sure all this complicated tech actually works as planned?
That's where building commissioning comes in. It's a vital process.
What does it involve?
It's not just a quick check at the end. It's a rigorous, systematic process throughout design and construction and into operation, verifying that all the systems, HVAC, lighting, controls, envelope, are installed correctly and function together as intended.
Like quality control for the whole building's performance.
Exactly. It gives the owner assurance that the building will actually deliver the design performance, reliability, and hopefully lower operating costs. It's crucial for complex buildings, especially glass ones.
Makes sense. You need to ensure the cure isn't worse than the disease, energy-wise.
Right. But the conversation now goes even deeper than just operational energy. It's moved beyond just aesthetics versus efficiency.
Towards broader sustainability.
Definitely. We're now critically examining the entire environmental impact. The rise of the sustainable construction movement is all about this.
Things like AE and green globes.
Those green building rating systems, yes, they force a wider perspective. Plus, there's a much bigger focus now on life cycle assessment, or LCA.
What does LCA look at?
Everything. From cradle to grave, basically. The energy and resources used to extract raw materials for the glass, The manufacturing process, transportation, the building's operational energy over decades, maintenance, and then, critically, what happens at the end of the building's life. Can the glass be recycled? Downcycled? Does it end up in landfill?
So a much bigger picture than just the electricity bill.
Much bigger. It forces us to confront the hidden environmental costs embedded in the materials themselves. And this relates to something Samuel Florman wrote about in The Existential Pleasures of Engineering.
What was the point?
He talked about how technology often has unanticipated but undesired consequences. His classic example was the automobile.
Nobody wanted traffic jams and pollution.
Exactly. But they happened anyway. The technology had these deterministic impacts almost beyond our control once it was widely adopted. And you could argue glass and architecture had some parallels.
The initial dream was transparency and modernity.
But the unintended consequences included massive energy demands and comfort issues, challenges we're still wrestling with. It's that pattern. Solve one problem, maybe create another.
So Florman would say we need to be careful about just blindly chasing progress.
Yes. He specifically warns us to beware of slogans. Calls for efficiency or progress can sound good, but they can be misapplied or hide deeper problems.
Like greenwashing.
Potentially. Or just not thinking critically enough about the real systemic impacts. He worried we might make the same mistake with an idea like social responsibility, making it an empty phrase, instead of engaging in rigorous, thoughtful analysis.
Which brings us back to glass buildings. Are they always the most responsible choice, even if they look sleek and modern?
That's the debate. And it ties into another really interesting idea, this one from Stuart Brand's book, How Buildings Learn.
About buildings changing over time.
Yes, he talks about grand final solution buildings. Buildings designed so perfectly, so specifically for their original purpose.
But they can't adapt later.
Exactly. They obsolescent have to be torn down because they were too overspecified to adapt easily to anything else.
And you think some all-glass buildings might fall into that trap?
It's a valid question. Are these highly specialized, energy-intensive glass envelopes truly adaptable for the long term? What happens when energy costs skyrocket, or climate conditions change drastically, or occupant needs evolve? Is a building designed for maximum transparency today truly resilient and sustainable for the next 50 or 100 years?
That lack of adaptability could be a huge hidden cost.
It really could. It makes you question the long-term wisdom of prioritizing a specific aesthetic over flexibility and resilience. What kind of legacy are we building?
Wow. Okay, so we've covered a lot of ground here. We started with glass as this incredibly rare, precious thing, almost magical.
Used in tiny amounts.
Then we saw the 19th century breakthroughs, plate glass, iron leading to things like the Crystal Palace, a whole new possibility.
The dawn of the transparent age.
Followed by the curtain wall, fundamentally changing how walls work, allowing for those all-glass skins that redefined our cities.
And the parallel development of high-performance glass IGUs, low E coatings, double skins, trying to manage the consequences.
Right, trying to make that transparency comfortable and hopefully more efficient with incredibly complex systems and careful commissioning.
But it remains a challenge.
It really does. Which brings us to the paradox. Glass. It's fragile, yet it lets us build these monumental towers.
It offers transparency, connection, light.
It can create those energy-guzzling hothouses.
It's a symbol of modernity, pushing design forward.
But it's right at the center of really tough environmental debates in building science today. A constant tension between aspiration and consequence.
It really is. The story of glass in architecture, you could say. It mirrors human innovation itself. That constant push for something new, something better.
And the sometimes surprising, often complicated results that follow.
Exactly. So as we keep building with glass, refining it, finding new ways to use this, let's face it, still kind of magical material. The real question maybe isn't just, what else can we do with it?
But what should we do?
Precisely. What kind of transparency do we really value? What are the true costs, environmental, energetic, even social, embedded in these choices? How do we build responsibly, considering those complex feedback loops between our buildings and the planet?
It leaves you thinking, doesn't it? What kind of transparent legacy do we want to leave behind?
That's the question to ponder. Every material tells a story. The story of glass is particularly complex, and it's definitely not over yet.